Welcome to our session on circuits and controls. Today, we're going to dive into electrical diagrams and drawings, which are absolutely essential tools for any gas technician.
In the gas industry, you will encounter three main types of electrical drawings. These are pictorial diagrams, ladder or schematic diagrams, and wiring or connection diagrams. Each serves a specific purpose, from helping beginners understand a system to guiding technicians during complex troubleshooting.
Let's start with pictorial diagrams. If you have ever looked at a basic installation guide, you have probably seen one of these. They are designed for folks who might not have extensive electrical training. The components are drawn to look exactly like they do in real life, and the wiring is usually color-coded, making it very easy to visualize the physical setup.
Next, we have ladder diagrams, also known as schematic diagrams. Unlike pictorials, these do not show you what the components look like or where they are physically located. Instead, they show how the circuit works electrically. The left side represents the incoming hot voltage, the right side is the neutral, and the horizontal lines, or rungs, contain the switches and loads. This layout is perfect for understanding the sequence of operation. Because ladder diagrams don't use realistic pictures, they rely heavily on symbols. As a technician, you must learn to read these fluently. Some common symbols include single-pole, single-throw switches, normally open and normally closed contacts, transformers, and relay coils. Recognizing these instantly is key to diagnosing system issues.
Now, what if you need to actually wire the system in the field? That is where wiring or connection diagrams come in. Think of a wiring diagram as a literal map. It uses symbols like a ladder diagram, but it shows exactly where the wires physically connect between devices. Importantly, these are almost always drawn in an at-rest state, meaning the main power is off and no devices are operating. Sometimes you will need to create your own wiring diagram based on a ladder diagram. To do this, first draw the physical components on your paper. Then, translate the circuit rung by rung. Always start with your highest voltage, like your 120-volt line power, and work your way down to the lower voltage control circuits, like the 24-volt side of a transformer. Let's look at a practical example using a two-zone boiler system. You start at the L1 line power connection on your ladder diagram and trace the first rung. Then, you draw that exact same electrical path onto your schematic diagram, making sure to connect to the proper terminals, like the common terminal on a relay center. You repeat this process, tracing and drawing, until the entire circuit is mapped out. To wrap up, remember the distinct roles of these three drawings. Pictorial diagrams give you a realistic visual. Ladder diagrams explain the logical sequence of operation, and wiring diagrams provide the exact roadmap for field wiring and troubleshooting. Mastering all three will make you a highly effective and efficient technician.